Okay, yes. And the event is starting and we're live. I'm so happy that we are live. Welcome to the Virtual Jug December 2019 edition. This could be the latest Virtual Jug session in a decade, right? The year is ending, the December is ending, the decade is ending, and we are here, and this is a glorious moment. I hope you can see me, because this is Zoom, and we're having technical troubles with Zoom, which is an incredible piece of video conferencing software that allows us to host Virtual Jug, which is an online-only Java user group over the internet, right? The speakers, the worldwide renowned experts join the Virtual Jug remotely, and we don't have to collocate everyone in a single piece of space, and that makes it very, very, very unusual. So I'm very happy that you're watching us now, or you're watching this later on YouTube. And my name is Alex Shalaev, and I'm very happy to see all of you here. You should join the Virtual Jug community. It's very easy. Go to virtualjug.com and hit the join button. But before we start our session, and before I say hello to our incredible speakers today, Bruno and Roberto and Bruno, I need to show you a couple of slides. I hope you can see me in a second, right? Share my screen, the desktop, share, boom, play. I hope you can see it. So my name is Alex Shalaev, and I'm a developer advocate for GraalVM, which is a kind enough project to kind of make my time here worthwhile. So it's a high-performance polyglot virtual machine. Check it out. Just go to www.graalvm.org, and you have the information there. And I'm sure the name will come up during the session as well. But that is a coincidence. Right. I would like to say thank you to SNCC, which is the company that does developer tooling for security, specifically for scanning vulnerabilities in the open source dependencies. Thank you, SNCC, for providing us with the Zoom account. If you watching this live, then please join the Virtual Jug Slack channel, the channel live session, where we will have questions and we can communicate during the session, and then we can ask questions from the participants, from the participants to the speakers. So if you have a question to Roberto and Bruno, you can type that in the live session channel, and we're gonna find an opportune moment, and I'm gonna ask them. You're welcome to share the group and session in general, Virtual Jug, or this particular session. Any social network will do. Maybe share a recording afterwards. And if you have any feedback, just go to and talk to Virtual Jug or directly to me at Shalaev. If the quality of the video is not up to your expectations, just please use the icon, the cog icon on the YouTube video, and it should go up to 720p. So it should be pretty crisp. Right. So today's session is called Quarkus in Real World Deployments, and we have two speakers, Roberto Cortes. You can find him on Twitter, but he goes by @RadCortes, and Bruno Baptista, and he goes by @BrunoBat_. A little bit unconventional Twitter handle, but you can find them there. You can ask all the questions. If you don't have the chance to ask them now, you can ask them later, and they will be absolutely happy to talk to you. So this is what we're gonna do for the next approximately an hour, and just go with Virtual Jug, spread the word across the world, talk to us, and let's enjoy content about Quarkus in real world deployments. So I'm gonna, how do I stop sharing the screen now? So with all that away from our I hope the video actually showed my slides. Because,
it did, no worries.
Very good. Because I thought this Zoom was just highlighting, Roberto, your screen, and while I was talking, everyone was looking at you. So I hope that was not the case. This is Roberto. Hi, how are you doing? Are you joining us from Portugal?
Hi, Oleg. Yes, I'm joining from Portugal. Thank you so much for hosting us. And it's kind of interesting to be on the other side, because as you know, I also help to run the big jug sometimes. And I think I've never been on the other side, actually.
Yeah, I know.
It's everyone as well.
Hi, Bruno. Bruno, you're also from Portugal, and you were you're working together on at Talk Desk, right?
Yes.
Exactly.
Very good. So yeah, hope you guys have fun. I will try to ask questions as they come.
Yeah, feel free
but
to
like
to send it
not
our way.
yeah, absolutely. And just if you have anything to say before the session, just go ahead. I hope you'll enjoy this, and then you
Yeah,
can come back as more.
yeah, wonderful. Yeah, so much. Thank you so much for having us here. So let me start by sharing some slides, and we'll take it from there. So hopefully, no, let's do it that way. And you guys able to see my slides, right? Yes?
Yes, yes.
Okay, wonderful. So hi everyone. Thank you so much for joining this VJAX session and see our session about Quarkus and real-world deployments. My name is Roberto Cortez, and I have here with me my colleague Bruno Batista. And so we work for this company called Talkdesk, and this is our story about us adopting Quarkus in the company for some services that we wanted to implement, and now we're actually spreading that for the entire company. Okay, so the agenda that we're going to have a look into today is going to be, we'll talk a little bit about what is Quarkus exactly, and what would you think about Quarkus. You're going to do a bunch of demos regarding Quarkus, and in the end, we want to share some of our thoughts about what was our experience, at least in this cycle where we were developing Quarkus applications. So we want to share some things that went okay, some things that didn't went that much okay, but you'll see it in the end. Okay, so Quarkus. So if you haven't heard about it, so this is a new framework coming up from the Red Hat folks, and this is their logo. So it's quite interesting logo, and usually when you want to learn about something, right, you go to their website and you start reading about it. So one of the things that the Quarkus say that they are is they call themselves supersonic subatomic Java. And the reason why they call themselves this way is because they want to provide a framework that's very, very lightweight, both on CPU and memory. So it allows you to actually deploy in cloud in a very friendly way. So the idea here is, especially when you think about Java and the containers that exist around Java, right? Those usually are some kind of heavyweight containers. Even what we call lightweight containers cannot really be compared with things like Go or Node, because just by starting up the JVM takes a bunch of memory. So this actually is not optimal when you're thinking about the cloud, especially because you end up having to pay for what you use. So like CPU and memory, especially. So even when you're thinking about deploying something on the cloud, and you take maybe, even if you have like a very small app, a Java app that you're running maybe on Spring Boot or some other container like Wildfly or WebSphere Liberty, Glassfish, doesn't really matter. Even if you take just 5 seconds to start up, those are 5 seconds that you're using on your cloud provider that you have to pay, but you're not really doing something with your app during that time. So it's just initialization start time, right? So the idea is that Quarkus, it's going to fix some of those issues by becoming a container-first framework, and they do support a lot of other tools that you can use. So we're going to see a couple of them later. If you're used to do imperative style programming, you're fine. If you also want to start doing some reactive things, it's also fine. Quarkus also supports all of that. And one of the interesting things about Quarkus is it's actually very developer friendly. So if you haven't heard about Quarkus before, we're going to show you something called Quarkus Dev Mode. And maybe for people that are already using Quarkus, they already know about this, but actually this is a really big thing, because it actually allows you to develop your applications without having to restart your container, and you can just code and see the changes right away. So, hey Oleg, I know that that you used to work on something called JRebel. So I'm guessing that now with Quarkus we don't need JRebel anymore. So sorry about that.
But this is fine. It was a long time ago, and
yeah,
I think Durable is an excellent product, and I know
oh,
there are a number
definitely.
of
Definitely.
there were a number of alternatives that people used over the years, the DCEVM, the Spring DevTools, and others. So I guess Quarkus reloading mechanism is kind of similar to those.
Yeah. And so if you look now into this slide, probably most of you are going to recognize some of these logos. So we see Hibernate, we see Camel, we have Kubernetes, we see Infinispan, we see Kafka, we also see MicroProfile, and there are many, many more. So the idea is that Quarkus is actually full stack, and all of these frameworks and libraries are already supported by Quarkus. So when you actually see and when you think that is Quarkus something really new, well, I actually don't think so. Because when we show you some of the code that we wrote, you're most likely going to recognize most of the code. So you're not going to see any Quarkus related code inside. So what actually changes is the glue code that the framework provides that you usually don't see. So the idea here is that you can still develop your applications that you've been doing for the last 10 years if you're using technologies like Hibernate, Camel, MicroProfile, REST Easy, and a few others. And this actually means that there is not that much of a period where you have to learn the technology because you're already using these technologies for many years. So you're still going to do the same things that you've been doing for the last couple of years, right? But the idea with Quarkus is it's now tailored for new paradigms, and this paradigm is the cloud. So what were requirements when we were actually thinking about this? So the idea is, of course, we want to do a bunch of services and want to do a microservice architecture. And of course, we wanted to deploy it on the cloud, and we wanted to support something kind of like a polyglot environment where you can able to support multiple languages at the same time. So this is not done with Quarkus itself. It's done with something called GraalVM that we're going to talk a little bit later as well. And wanted to have somehow of an event-driven architecture where you can just send events from one service to another. So this is pretty much very standard things. Now, yeah, so if you say microservice one more time, I'll shoot you. Some other requirements is, well, we're going to have multiple services. We're going to have some longer running actions. So even Quarkus, it's more you can use it for serverless stuff. We're just going to run it as a long running action as well. And we're going to have some data pipelines where you're going to basically stream data from place to place, and we also want these to be asynchronous at some point. So alternatives, when we were looking into some services or some frameworks that we were going to use, well, of course, we evaluated Spring Boot, we evaluated other things like Micronaut, Drop Wizard, or Legume. And the interesting thing was when we were doing all of these evaluations and we basically were trying to implement a couple of services and try that out, I think it's safe to say that Spring Boot was a very high contender at that point, especially because if you look into Spring Boot, it's really awesome, and it has a lot of market share, so there's a lot of people using it. And coincidentally, Quarkus came out on that same week where we were evaluating all this stuff. So we started looking into it. We made a couple of prototypes, and we actually enjoyed the experience, even though it was really, really new framework. Well, not the stack. So we were still using the stacks that we knew of, like Hibernate and MicroProfile and so on and so forth. So it was not really that much stable, but we got confident that it was a good choice. So we kind of dive in head on, and we start using it from the first week it came out. And the interesting reason why we start looking into it is because if you look into Quarkus and if you look into why they say they have like a small memory footprint, is because they do something which is they remove all the reflection, they remove all the dynamic class loading, they remove all the enhancement, the bytecode enhancement. So some of the things that make your Java application slow at startup time. So they remove all of that and they do all of that in compile time. So meaning that when you start a Quarkus application, all of that is already resolved. So you can just start it up really, really quickly. And that's also one of the reasons why the hot reload in Quarkus is also easy to implement and it also works very well because one of the things that makes hot reloading hard is when you have to do all of those things like enhancements and class loading and reflection calls. So that doesn't exist in Quarkus on runtime. Even though you're running it on a JVM, it doesn't if you're using the Quarkus extensions of all of those libraries. So I'm going to give a little more detail on that later. But that's pretty much that's the idea. And that's the reason on how they were able to actually reduce the footprint on memory, reduce some of the CPU usage, and make these way better for cloud deployments. So I can also add that when we start using it and start deploying on the cloud, we actually use less nodes than we normally use because of those perks that Quarkus gives you, right? Okay. So why Quarkus then? So that was one of the reasons. One of the reasons is, of course, microservices. I mean, there are other frameworks that you can use, of course, to develop microservices, but Quarkus with MicroProfile, which is also a set of standards to help you develop those kind of services, works very well. The reason why it doesn't have reflection and all of the things that makes the runtime slower also allows you to build Quarkus as a native image in GraalVM. So even though GraalVM supports some reflection stuff, there is some things that are not completely supported. And one of the things that the Quarkus guys did was to actually come to those libraries like Hibernate and solve all of that issues for you at compile time, so you can actually build a native image with GraalVM. So I'm not sure. So we, of course, we are adding a lot of concepts over here. So even though this is not a session just for GraalVM, I'm just going to go really quick on GraalVM. So GraalVM, and I mean, we also have a very specialist here with us, which is Oleg, which actually works on GraalVM. But GraalVM is a new generation VM coming from Oracle Labs. And the idea is it does support polyglot features, plus it allows you to actually build these polyglot applications, especially Java or Kotlin or Scala, any JVM language, really, built into a native binary that you can actually run without a JVM inside. So we actually use something called Substrat VM to run all of that. And the idea here is you have like a concept of a closed world where you don't have reflection, you don't have dynamic class loading. Actually, it's not Java running anymore, right? But when you run it, when you build it as a native image and you run it as something like that, because there is no startup time on the VM or actually the JVM, then the startup time of the native image is actually super quick. So we're talking about milliseconds, really. And the memory footprint is also way slower. So in here, we actually have two things. So Quarkus itself is already smaller on footprint on memory and CPU when you run it on VM mode. But when you run it on as a GraalVM native mode, it's also even smaller. So Oleg, did I got everything right on GraalVM?
Well, like let's say that you were like the gist of that is correct, right? So GraalVM is a high-performance polyglot virtual machine. Yes, so we can run different languages, including R, which is specifically interesting for your case, and also JavaScript, Python, and so on, right? We can compile bytecode ahead of time into this smaller native binary, platform-dependent binary, which will start fast and have probably a smaller footprint. And then you went into not supporting reflection and stuff like that, and that is not the 100% correct. The reflection,
well, no.
reflection,
reflection is supported. There are other things like dynamic class loading is not supported, right?
Yeah, so dynamic class loading is a little bit more complicated story for the GraalVM native images because of the mentioned closed world assumption. So
yeah.
you can use it up until a certain moment. So that's how you can load dynamic proxies and everything that the libraries like Hibernate need during the image generation time. So there are it's a little bit new approach, right? So like you have to treat it as such, right? It's production ready, it's early adopter technology, and it can change in the future, but you can build upon it, and there are a number of frameworks which support that.
Yeah,
including Quarkus.
Yeah.
So I think now that is out of the way as well, and we can move forward.
Yeah. So this is not supposed to be a GraalVM specific talk, because there are plenty of talks of that, but at least there is this option with Quarkus. And we're going to show you a few demos running both on native image and both on VM modes. Actually, we actually run everything in production with the VM mode for now. Maybe we'll change that later for native modes. Okay, so a few other things about Quarkus is, Quarkus is all about standards as well. So me and Bruno, we love standards. So we used to work a lot with MicroProfile, as you know. I think we also have a couple of sessions about MicroProfile on the VJug. But so MicroProfile is a standard APIs to build microservices in Java. It's supported by a bunch of other companies. And if you think another specs like CVI, JPA, bin validation, JSON binding, JSON processing, interceptors, Java transactions, all of that is in Quarkus. Now, you might be thinking that Quarkus is a Java EE implementation. Well, it is not. They implement a couple of subsets, but it's not a complete Java implementation. But for us, it's fine for what we're doing. So if you're looking for a complete Java EE implementation, you're not going to find it in Quarkus, but we believe that what Quarkus gives you, it's more than enough. So that actually creates a sense of familiarity with what you're using. So even like a couple of weeks ago, I picked up a couple of applications that I was reading in Java EE and actually was able to run it in Quarkus because I was just using the exact same subset that Quarkus supports. And the community on Quarkus is it's really great. So if you look into the releases, they're releasing versions every 2 weeks. So they're doing like a crazy amount of work over there. Even today, they just released version 1.10 final. So when we actually start looking into Quarkus, even when they announced the project, there were already a lot of people contributing to it. So we think that that's a great community. I can also tell this story all the time, which is we found many bugs in Quarkus, and every time I found a bug, I was actually happy. And I was actually excited because I thought it gave me an opportunity to contribute to Quarkus. But on the other hand, I actually became a little bit frustrated because every time that I found the Quarkus bug, I went to GitHub and it was already reported, and in many cases was already fixed. So that actually tells you that they're paying attention to everything that's happening, and they're fixing the most annoying bugs all the time. And well, in the end, it's a new toy, and people like to play with new toys. So we actually want to try that out. Okay, so before going into demos, which we're going to show you over there, so we just came up with this really simplified architecture where we have a message bus with events where each microservice will just publish and consume events from these message events queue or topic. Doesn't really matter. And then each microservice has its own data store. So the idea here is you have a microservice. It will just do a bunch of operations. It will just publish an event. Then you have other microservices will just consume that event and will just perform a couple of other operations based on that information. It will store that data on its own data store. It may push another event to the queue, and so on and so forth. So we're going to show a more simplified example only with 2 microservices. So it's kind of like if you start putting more, it's going to complicate a little more. But this is the general idea, right? And a bunch of architectures are actually built this way into these days. Okay, so the actual stack that we use it, and that's the one that we're going to show in this example is, so we use REST endpoints, of course, using MicroProfile. We ended up using RabbitMQ for publishing the events. It can be Kafka. The company was already using RabbitMQ, even though we were migrating to Kafka at this time, so we just went with that. And then we start using Camel as well to make it easier to do the publishing and the subscribing of the events on RabbitMQ. So we do deploy everything in Docker and Kubernetes. So all of what we're going to show also, we publish Docker images with that. And then we run everything on Amazon EC2, and we just use S3 for file storage. So most likely, I'm not sure if I'm going to show the EC2 stuff in here because that's too much, but we'll probably going to run this locally with Docker in our boxes. So with MicroProfile, so we're going to use things like CDI, JAX-RS, JSON binding, and then configuration, health checking, JOT for authentication, Open API for documentation of the REST endpoints, and then REST clients or type-safe REST client to call other APIs. So pretty standard. Then RabbitMQ and Camel, we're going to use it to route messages from side to side. All of these are going to be asynchronous events. Those are going to be produced and then consumed by each microservice. And we're also going to persist them into RabbitMQ. So if for some reason the listening microservices are not up, they'll just be persistent on RabbitMQ, and when a service comes up, we'll just pick that up again, and they'll just process what needs to be processing without losing any information or data. So another interesting case that also pushes us to use Quarkus, and because of the integration with GraalVM, is, as I said before, and I'll confirm. So GraalVM as a polyglot JVM allows you to run multiple languages. So in some of our use cases, we have heavy computations that we perform in R. So we have a lot of data science people, and as you know, maybe Java is not the best language to write data science stuff. Even though that's debatable. But the pain point is it's quite hard to convince those people to actually write Java. So they like to write R or Python. So the idea that we had was to actually use the GraalVM API to wrap those R scripts and then bridge them with Java in a polyglot environment. So you can actually call these R scripts directly from Java and expose them as regular REST endpoints using a MicroProfile. So we actually got the best of 2 worlds. So they're able to write their own computations in R and perform whatever they like over there. And we have our safe environment or productive environment where you can have all the REST endpoints, and we can just validate everything that's going on and do some other operations, which kind of are like sometimes hard to do in Python or R. So for this was very convenient to use those 2 cases together. Okay, so I'll shut up for now, and I'm going to hand over to Bruno. So he will show you some of the code that we wrote, and he will show you some of the demos that we have for you today.
Hello, folks. Thanks for coming to this VJAG session. So let me start by sharing my desktop. I hope it's working properly.
Yes.
Okay. So this is a project that you can find on GitHub. I've shared the the link on the channel, so you can check it out for yourself. So let me explain you what we are seeing here. So with this project, we wanted to demonstrate a set of features that a production application would have to have, in our opinion. So on our company, we had the requirement of multiple services that would need to communicate between them. We had asynchronous communication. And once you have a lot of services, you also need to document them properly. If you are going to run them on a modern cloud, you also need them on a Docker image, and you need to configure everything. You need to health check the services, because if you deploy it on Kubernetes, it will require the application to be to provide health check endpoints and a few other features that we are going to see. So, and at the time that we were starting the project, and like Roberto mentioned, Quarkus launched publicly, we evaluated it and it seemed fit, and we started using it from scratch. And right now we already have services in production using it. And this is kind of a sample of the way we build microservices with Quarkus. So everything starts with this legume service, where we post legumes, and then an asynchronous message is sent to the hero service that transforms the legumes into superheroes. So this project has a parent POM, where we define all the dependencies that we are going to use here. And for Quarkus, usually those dependencies can be expressed from a BOM file, a build of materials, where you only need to define the group and the artifact ID of the dependency that you want to use, and the versions and everything else comes from the BOM that was defined previously. So for all the services that we are going to have on this project, we are going to use fault tolerance, we are going to use JPA, and Postgres for production. But for tests, we are going to also use H2, and we have it here as well. So this is kind of a realistic setup where you have a production database and also a database for testing. We also use OpenAPI to document our endpoints and also to expose Swagger UI, expose them through Swagger UI on development that we have here. And we also use Hibernate validation and the health check that I was mentioning before. So the Camel. So we have a curious, we use Camel extensively on our projects because it integrates easily with RabbitMQ, and also gives us the ability to integrate with S3 and process files, for example. So when we started to think about all these integrations, Camel looked like a neat approach for all these problems. So all our classes use Lombok. So the entities will be very thin, as you will see soon. Then the project POMs, they are very thin. So in this case, we have a library that allows us to have the Camel support here, and that's it. So
are you able to increase the font? Some people are complaining.
Oh, yeah. Yeah, sure. Okay. So I hope this is good for everybody.
Should be.
Okay. So now that we have a project structure with all the libraries, so before that, one of the things that you can see here is that all these libraries are conveniently packed by Quarkus. So this is the equivalent for the starter projects from the Spring Boot. So the way you define the dependencies on Quarkus, it's quite similar to the way you define those dependencies on Spring Boot, where all the classes are bundled in a convenient package, in this case through Quarkus. Okay, so then we build everything and we need to deploy it. And for that, we start with Docker files here. So this is the standard Docker file for a JVM project. As you can see here, it uses the OpenJDK. And when it starts with the Java managed jar. And in this case, we have a Docker file that's based on a Docker, on a native image. Sorry, I can see the first line. So, which has an operating system and runs an application from that operating system. This is not Java code at this point. So, and for convenience, we bring those Docker files from those projects into a Docker Compose. For this particular demonstration, the Legume service will run within the JVM, and the hero service will run as a native image. So we'll have both versions at the same time. And on the Docker Compose, we can see here the Docker, the hero service starting and a few properties. So this is a thing that we use from MicroProfile config. So as you can see here, this Quarkus underscore data source underscore URL, it's actually a property that we define here on the application properties. You see this? So when we have on a system property that exactly matches what we have on the application properties, Quarkus know from the MicroProfile standard that it has to map this to that. And it's quite convenient because in the beginning, we had a bunch of helper code when we started the service to map the properties with the application properties and the system properties. And it was kind of messy. And most of the projects still do that. But with MicroProfile config, at some point in mid this year, this was changed and we can use this convention. And it's a lot simpler because we don't have to have any code here on the bootstrap of the application overriding the properties. So we have the hero service here, the Legume service, and then we have a Postgres database that we are going to start here, a RabbitMQ server, and a neat portainer, which will allow us to see the Docker images and manage them as we go along. So let me start a console. Okay. Okay, I think this is good enough. So, and to start the Docker container, first you need to, the whole environment, you need to build the Docker Compose. Everything should be kind of up to date. So I didn't show the lengthier part, which is building with Maven. In the case of building the JVM image is quite neat. It's just a standard Maven clean install. But when we do it with a native image, we need to execute a specific profile, the native profile, but using GraalVM. And that takes quite a while, 12 minutes on my machine when using Zoom, which is quite lengthy, because it tries to optimize the code to generate a native image. So to start everything, we just do docker compose up, and we should be good to go. Okay. So the hero service gives a few errors in the beginning because it starts too fast and the RabbitMQ cluster is not ready yet. We don't have any feature here that slows or waits until RabbitMQ is up to launch the service. So let's go to the browser. So remember Portainer? So Portainer does this for you. So it creates you a service that exposes the endpoints in a neat way. So I have here 5 containers. So the hero service, the legume service, the database, Portainer, and RabbitMQ. And everything's running. And we can see the stats, for example. So here for the hero service, and here for the legume. Oh, but it requires authentication. Okay, that's fine. This one probably as well. Okay. So we are going to see the hero service stats on this one. And on this one, we are going to see the legume service stats. So as you can see here, this is the JVM service. Right now, the memory the allocated memory is around 360 megabytes. The native image, by contrast, is using less than 8 megabytes of RAM. So the native image is quite efficient in terms of RAM usage, and it starts quite fast. We are going to see that later. So you can argue that on the space that you use a few JVM-based services, you can use probably a few dozens of those, or almost dozens of native image services. Okay, so let's give it some load now. So, okay, let's create a few requests here. So let's do a curl. Oh, actually, let me copy the request from here, which is simpler, which you can also do. It's this one. And we are going to add a legume. But first, let's see what's in there. So sorry, need this one. Okay, so we have a failed legume. Interesting. I wonder why. So let's go here. Because you shouldn't have failed legumes at this point. I'll explain later. So let me do a health check here. So the health check endpoints are standard and will be on your application path. Health/live for liveliness. So everything is up and ready for readiness. Oops, There's a space there. Okay, so everything is ready. Interesting. So we have a fail legume in the database or something. So what happened here? We went to see what we had on the database. And now we are going to post the broccoli that we have here into the database. Okay, so we posted a broccoli, and the service gave us an ID for that broccoli. And if we are going to see the log, let me decrease this a bit because it's super large. Okay. So a new message has arrived, and we received the broccoli, and the superhero received that message that was sent asynchronously through the Legume service and created its own hero. So if we go to the database and check what we have there, let's get this. Oh, how do I go out of here? Okay. Go here. Okay, we have the legume, broccoli, and then the super broccoli on the other side. Oops, it's restarted. So this happened because I have a connection from the previous container when I was testing before the session, and now it is connected and is trying to log in again. But the results should be what we saw before. But it's just annoying. It tries to reconnect. Okay, so the legume and the super broccoli. So let's go back to where we were. I don't know if there's any questions until now. Let me check here.
Actually, let me ask you a few questions. Since you are doing this, or maybe I can bother Roberto with questions, and you just ping us.
You can bother me.
Right.
Yeah,
so
go ahead.
We have a bunch of questions, and some of them are answered. So I will not go over the details. For example, GraalVM and Quarkus both have open source. Both are open source projects, so we can use both of them as open source projects, right? And then the name Quarkus, why it is called Subatomic Java by Praveen, it's a reference to Quarks, as Bruno responded. However, I have other questions specifically in the YouTube chat, for example. So like a YouTube chat dweller is asking us, does Quarkus support HateOS?
HateOS? Oh, HateOS.
Yes.
Yes. Okay.
Yes.
Well, yeah. I mean, one of the things. So so let me try it. I want to keep this answer short, but let me see if I can make it short. So Quarkus, you can use pretty much any library that you like with Quarkus, right? So one of the things that the Quarkus people did, or the Quarkus team did, was to create extensions on a lot of libraries to remove the reflection, to make it easier to build it to native mode and to make it lightweight and so on and so forth, right? But that doesn't stop you to actually add other libraries on top of it. So all the Java ecosystem that you have available for you, you can use it. So if you for instance want to use some HateOS library to provide on your REST endpoints, you can use it. That's just fine. But basically what you're not going to be able to do is, if that library uses heavy reflection or dynamic class loading or enhancement, maybe you're not going to be able to build it as a native image, but you're still able to run it as a VM mode on the JVM. So that's the point that I want to make. So you're not when using Quarkus, you're not only closer to use the Quarkus things or the Quarkus extensions. You can use pretty much wherever you like. Now, if you want to actually have that particular library to be run as a lightweight version, then you have to implement a Quarkus extension on top of that to remove all of those things, and then you're able to do it. But if you don't want to do it, you can still run it safely in the JVM mode. You will run just fine, and all the dynamic class load and enhancement and reflection, everything supported just fine. I hope that clears that up.
Yeah, I hope this answer clears it up. You keep saying reflection is a trouble.
Sorry. Yeah, no, there's not trouble. Yeah.
It is
not. It is not trouble. What I'm saying is it is not trouble on the GraalVM. But what I'm saying is, so for reflection, it's something that. So in this particular case, when I was talking about reflection, it was not about not being able to run it on the GraalVM or the native image. It's just, for instance, reflection is one of the things that. That takes more time on the runtime, right? On the JVM mode. So when you don't have a reflection call or when you don't have reflection in it, your code is going to be much faster. So just as an example, are you talking, Oleg? And we're not hearing you.
No. I was just. It feeds exactly into the next question by Mora.
Okay.
Is if you will. Sorry for interrupting, but it just goes into that. So Mora Monty is asking how much of the time that we save at Bootstrap removing reflection, class scanning, and etc. is moved to build, and what is the experience that you guys have in this aspect?
Yes,
right?
I guess that's a very good question.
Yeah, it's orders of magnitude, actually. Several orders of magnitude.
So, and I mean, this of course, it may vary with your particular app, your particular sample, and particular libraries that you're using. So for us, we tried a couple of Spring Boot applications, and I think Bruno has the numbers. He actually wrote a blog post about it with a couple of samples. But we were talking about maybe 3 times more. And as a runtime, and on compile time, it doesn't add that much time. I'm guessing just a couple of seconds. So it's not really that problematic. And if you run it as in developer mode, then it's even better. So one of the things that Bruno haven't shown was developer mode. So maybe I'll just gonna show that very quickly.
I was going to do that next.
Oh, okay. Okay.
So if you want, I can continue.
Yes. So he can show you developer mode because when you run that as a developer mode, then things like deployments and compile times and start time doesn't matter anymore because you actually don't have to do that all the time like you usually do when you're building an app or when you're developing an app.
Right. Can I ask a follow-up question here?
Sure.
If you will. But humor me. So when you run developer mode in development, this is one good thing. But you're running Quarkus microservices and you run them in the JVM mode. So you run them on the JVM.
Yes.
Yes.
Right?
Yes.
What's a typical startup? What's the typical startup time that you are seeing?
For dev mode.
For production. I mean,
you're
running them in production.
Well,
6,
depends on
7
the box,
seconds.
but, we're talking about 2 seconds.
Well, yeah. On my machine, it's like 6-7 seconds. Yeah.
Well, he has like a crap machine.
Okay, so it's a few seconds. Very well.
Yeah, we're talking like a couple of seconds. 2
so,
seconds.
Right.
I can tell you that the equivalent code from Spring Boot to Quarkus with the REST endpoint that posts things to a Postgres database with JPA, that's pretty much the code that we are seeing here was starting around 2-3 seconds on Quarkus, and was taking a lot longer, for example, in Spring Boot. So
right. No, I just wanted to like understand the order, like.
Yeah. So Bruno actually wrote a blog post about it, so maybe he can share it later, where he has all of those comparisons.
Yeah, I can share the link later on the live session.
Okay.
So let me continue then.
Yeah, absolutely. Bruno, up to you.
Okay. So let's go. So now I'm going to show you details on the code itself. So I suppose I'm sharing the screen now. Okay. Okay. So the application has a fairly enterprisey feel. So the Legume service has a Legume API interface where we put all the open API annotations. As you can see, they are super verbose and lengthy. And if we put everything, our runtime code with the annotations of open API in the same place, the code itself would be, in the middle, and it would be hard to find. And this way, we just implement the resource, implementing that interface that has all the annotations. And as you can see, the code is super clean and like before, we're using OpenAPI. So the model, it's the Legume. So we have a standard JPI entity with an ID, a name, and a description. We are using the bin validation here for not blank for the name. And as you can see, we are using Lombok to create a builder, to say that it's a data, to create the getters and setters and all that. So this is how a Lombok entity with JPA looks like. So to abstract to the outside, we have a Legume item that's used to read, and a Legume new that's used to create new legumes. We don't have the ID here because we cannot define it on the client side. So we don't have it, so no one has to figure out an ID because it doesn't make sense on this case. So here is how we implement our health check endpoints. And here's how we wire the Camel code to send the messages. And so let me take you to one of the features that I personally like the most. So remember that before I was thinking about how the hell I had a failed legume in there. So, and I think I found the answer. So this was the first time I was using the list, and I have a timeout here of 50 milliseconds. And the first time I run this code, it took a bit to allocate all the memory and give the response back. So I think it failed at 50 milliseconds on my crappy machine. So it gave me a fallback. So the fallback does exactly that. When this code either doesn't return on the specified amount of time or gives you an error, it falls back to the fallback method, which is this one. And it gives you a failed legume. So it always gives you something back, not an error. And this is one of the applications of the fault tolerance API, which we can see here in practice. So if I go here and kill my database, or stop it to be less brute, I will not have a database anymore. And it takes a while to stop. So something here happened. And then when I call the legumes list, you see here, I have the failed legume, because in this case, I had an exception because I cannot access the database. So if we go to the health check, and so the liveliness will tell you always that the application is live because the endpoint is up and it's there responding. So it's up here. But the readiness, you can implement multiple checks to see if the application is behaving properly. And the readiness will tell you that it's down because it was unable to get a JDBC connection. So you can have this monitoring your application in real time and be aware of all the problems going on. So of course, this will recover automatically when we start the database again, and the readiness should be okay or not. Oh, it's up, takes a while. And now when we call the legumes endpoint, we will not get the fallback, we'll get the real response from the database. So this is one of the things that the fault tolerance allows you. In here, so I mentioned before the MicroProfile config. So here on the live check, one of the things that I have is I'm injecting here a property called live property. So when I call the live endpoint, you have here the config property being injected, and this is the text defined in the default from application properties. So, and this comes from this property that we defined here on the resources. So we can override this as well on the containers on the environment that we have outside. So this is just a demonstration of how we can use the MicroProfile config to pass configuration to our applications. So now let's do a demo for the development time. So how we do development time with Quarkus. So let's stop all this. And let me just make sure that everything is down. Okay. So we need to get up the database. And RabbitMQ. Let me check if the right names for this. So this is also on here on the properties. Maybe I wrote something on the file when I was going around. Oh, yeah. Okay, so I want just to start the database and the RabbitMQ server. Okay. Because right now I want to go to each individual project. For example, I want to go to the legume service, to the target, and see what's in here. So because this is a JVM-based service, I have it just the runner here. Let me open another tab. And let's go to the hero service. And in here, when I built this with GraalVM, it also created this executor. So I'm gonna start the service here but I'm gonna tell him to run on a different port because they would clash. I'm doing this on Docker Compose. I'm mapping the ports properly, but here I need to do it manually. And I'm gonna tell it to go to 8081 or something. So you saw this, it started in 88 milliseconds, and this is the time it takes to start a native image. So this is why this is used on serverless functions on the web, where you can effectively start a service to reply to a specific request. You don't have to have a server always up. You can start it on demand. This is why, because it's super fast starting those things. But not on the case of the JVM-based services. So we can start them with Java manage jar and calling this file. But on this case, I'm gonna use the dev mode, and for that I'm gonna use the Maven Quarkus dev. And it will automatically start the remote debugging port first here on 5005. If for some reason I want to debug, and it will start the rest of the service. In here, it took like 8 seconds. Probably if I start it again, it will be faster, but with Zoom working, I don't believe so. So, and it's up, and let's do some things with this. So, so Roberto mentioned back that we could execute code here, change and execute the code on demand immediately. So let's do that. So before we were let's call an endpoint here, just as a starting point. So let's get the legumes. And let's call the init endpoint. This will create a bunch of legumes for us. So it created carrots, zucchinis, and other things, and an orange. Oh no. And for example, if we call a start endpoint, there's nothing called start in there, so it will fail. So, but if we go to the code and tell it, okay, this is the start endpoint, so you will be able to see the code here is reloading, and now I can call it, and it will create additional legumes for us. Yeah, these will be different, I suppose. Hope so, at least. Okay. Well, that's interesting. Oh, yeah, I'm doing a post on legumes. It doesn't like it because I'm not posting some of the fields. Okay, so now I listed and I have more things. So this, I reloaded. This is not just a simple, well, I could go here on any method and add some code. So before this, I could just system print out something, but the live reloading can be affected. Also listens to things that I do on annotations, everything pretty much. Don't know if you want to see something in particular here, Roberto?
No, I don't think so. I guess that people got the idea. What do you think, Oleg?
I think it was a good demo, specifically for the dev mode, and the code looks and feels like, right. I think I even me not being a professional kind of Java EE developer for a long time, right? I think I can recognize the patterns of this code. So I think the learning curve is indeed not not an issue here. We have a quick question, maybe, since we kind of broke the flow.
Sure.
Anyway.
Okay, go for it.
Vorpen from YouTube is asking, is Quarkus only meant for server-side apps? What about native compiled desktop apps?
That's a very good question. I mean, I never tried to use it as a desktop, but I'm guessing that it shouldn't be that hard to actually use JavaFX. I'm guessing that he's referring to use JavaFX as a desktop app, right? But I don't see any reason why it shouldn't be able to use both together. Again, it's everything is Java, so even if you're not using Quarkus to its full potential, you'll still be able to use it anyway.
So you can see it as another CDI container that you can execute everything CDI related.
Right, right. Are you gonna sorry? Are you gonna continue with some slides, or are you gonna wrap the session
let me.
up somehow?
Let me.
Or
I mean, I know we're pretty much out of time, so I can do like a quick set of slides just to wrap things up super quick, I guess. There are way more. Yeah.
Sorry, Bruno, if you have other demos, then we can.
Oh, that's plenty more things. I was going to show you how we do the integration test, but you can look at the tests and see how we do rest assured to call the endpoints and get the responses and so that and all that.
Right.
And well, there's also a part related with our code where we start our code and we basically wrap the R code around the REST endpoints, and we can call them and execute whatever we want through REST API on R.
That would be very interesting for me personally, but I am afraid that is going to take a little bit too much time. So maybe we should collaborate on explaining that in a blog post or
yeah.
So later. So maybe Roberto, you just take it.
Yeah. So regarding that R, just really quick. So you guys already have the address for the GitHub project where you have all of that. So there is instructions for you to go over there and you can run everything on your box. Hopefully, if they're okay, and we hope they are, so you can run that R sample over there directly, so you don't have to show it. Okay, so I'm gonna do like this super quick. So just to wrap things up, let me share again. Here we go. So you're guessing that you're able to see my screen, right?
Yeah, it's okay.
Slides, wonderful. Okay, so some of the challenges that we have. So we completely started from scratch, right? We have a lot of effort setting our infra, but it was not only Quarkus related. We're also starting completely fresh in our company. But we have so many integration challenges, and I've been from some of them before, so it was a relative, even though the framework itself is new, well, as we've seen right now, and what Bruno showed you is you don't see that many Quarkus imports over there, right? So you're still using all the standard stuff, but still there was some bugs because all the integration code that Quarkus is new. So some things sometimes didn't work as expected. For instance, places where @inject were not working, or some CDI meanings were not being recognized. But those were actually fixed pretty quick by the Quarkus team. So, and again, I actually got a little frustrated when I found the bug, and I was happy to go there fix it, and it was already fixed, and I put it for the next release. So I only have to wait a couple of weeks until the next version came out, or just come up with a snapshot version until it was not released yet. And yeah, so as I mentioned before as well, Quarkus has a really quick release cycle. They release every 2 or 3 weeks. So if you keep upgrading all the time, so sometimes when you upgrade, some stuff breaks. So that's usual. So you have to live with it and just keep reporting the issues and help them fix that. Hopefully, Quarkus will become way more stable when in the future. Right now, it's still on early stage, but we're already running in production. So I think this is what it says, living on the edge, right? So, and we were more than happy to actually accommodate all the effort required, which is not that big to be able to do that. So some of the shortcomings in Quarkus that we found, so there are some CDI limitations. CDI is not fully supported. I'm not going to go into details. They have like, if you go to the documentation page, they have like a full web page telling what they support, not support on CDI, especially because CDI was thinking about or was thought about running on runtime, and now they're doing things on compile time, which sometimes doesn't match completely. So native image compilation is super slow. It is not related with Quarkus itself. It's related with native image binary from GraalVM, and especially related with your hardware. So if you increase memory, it will improve. But when you build a native image, you may end up, for instance, that those particular projects in my box, they build in like 7 or 8 minutes just to build the native version. So if you have people that build C code before, so that's the same thing. So that's the same timing that you will expect. Some libraries that you use may not work on native mode, and that's because of the reason I told you before. If those libraries are using features from Java that are not supported by GraalVM, for instance, dynamic class loading, then those will not work on native mode, and you're not able to build the project in native mode. But you're always safe, and you can run it in as a Java VM mode. So are you locked in some kind of technology? So if you look into the project that Bruno demoed, what did you see different? An application.properties, which is specific from Quarkus to do configuration. You have an annotation Quarkus test, and that's basically to set up the runtime when you want to run a JUnit test. So that's also specific. When Bruno show you also the Maven artifacts, they're also specific for if you want to use those artifacts that are able to build as native. So that's also specific. And well, you're still going to be locked into the EE/MicroProfile world. But again, just a couple of weeks ago, I just migrated an application from EE, was running on Tommy and Wildfly to Quarkus, and I didn't have to change that much things. It was just the POM file and a couple of things here and there, and I was up and running in a couple of hours. So you'll still be locked into Java EE, now Jakarta EE, and MicroProfile, but you can still easily move between servers over there. Some cool stuff about Quarkus. So the library loading feature is one of the things. Another thing is a single jar with just your code, which is super great when you're building Docker images because they split the layers into a libs folder and an application jar. So when you're building Docker image, it's super quick because then you're just copying the code that you just wrote, and all the libs are already over there. So it's just saves a couple of seconds here and there. So in the end, it's going to be a lot of stuff. They ship with a lot of out-of-the-box stuff. So config, Bruno already showed you that. Also, for instance, Flyway, if you're doing a database migration, they actually ship with a coarse filter. So every time that I have to build an application, I end up building a coarse filter. So now they have a coarse filter. It seems very small thing, but it's there. It's something nice that you have to code. The documentation is actually pretty great for a new project. So if you go to documentation, you're able to find a lot of tips here and there and way to do things, not related with Quarkus itself, but they're just generic documentations on the frameworks or actually the libraries that they're using, like Hibernate and JAX-RS and MicroProfile config, health checking, and so on and so forth. So performance seems way better on the JVM. The native image performance also is promising. So it's interesting for calls for less startup time and memory usage. But the early performance test that we have done is that on native image, we seem to have less throughput. And here is just a table with that. So we use that GitHub project to do performance testing. And they also perform testing with other libraries like Micronaut and Spring Boot and WebSphere Liberty. I didn't want to include that over here because I'm only talking about Quarkus, and I don't want to start a fight with all of that. But here you'll see very similar timings as Bruno was showing in Portainer. Now regarding throughput, so native image does seem to have less throughput, and the reason for this is because the profiler the JVM has running on runtime is way powerful. But I know that, and I'm guessing that Oleg can confirm that as well. I know that the GraalVM people is also working on a profiler to improve the throughput and runtime code running to make it faster and make it more similar on the performance that you have when you're running as a JVM mode. So do you think that this is production ready? I think it is. So, but you have to use it at your own risk. And I'm guessing that it will be the same as any other open source technology. Native mode is still on early stages. So I think it's okay to use, especially if you have a multi-node application and then you can mix up a couple of nodes with VM modes and a couple of nodes with native modes. So it works very well. And for now, we are definitely fine, working very well for us. So maybe you want to try that and see if that works for you. Some final thoughts. This is a well-known stack. So if you've seen what the code that Bruno shows you, it's probably the same code that we're building in the last 10 years or more. So it's not going to be very high investment you have to do. It's still growing. They're still adding a lot of extensions to support way more libraries as native mode. So give it a try and see if that works for you. And questions where they have all of that. So I guess I'm not sure if you have anything else. But if you don't, please feel free to reach us out after the session anytime that you like, and we're happy to answer any of your questions later on.
Right. I don't think we have any. We have one kind of question in the live session chat. Thank you very much, Roberto, for the conclusion to this. I think it's a great summary of what you experienced was moving to, well, creating new applications with Quarkus. There was this quick question by I think Praveen in the Slack channel, right? And then just for everyone on the video to follow up, right? Can Quarkus be run on OpenJDK or Oracle JDK, or is there a tight coupling with GraalVM?
No, I mean you can run Quarkus on any VM. Right. So when you run it on VM mode, it's JVM mode. You can run it on a hotspot. You can run it on .OpenJDK, OpenJDK, Red Hat JDK, Azure JDK, Amazon JDK, wherever. So it's still Java, right?
Actually, the Docker images that we were using, one of them used the OpenJDK, and the runtime that I used when I did the developer mode demo was adopted JDK as well.
Right. So right. you only require to use GraalVM if you want to run polyglot stuff, then you require GraalVM, and you do require GraalVM as well if you want to build it as native.
Right. So exactly the polyglot capabilities, and when you run your microservices that use R, you run them on GraalVM, right?
Yes. That you require because the regular VM doesn't have polyglot stuff, right? So you do require GraalVM for that.
Right. And then technically you would be able to run any Java application with like Spring and Micronaut or any other server and have still those polyglot capabilities while running on GraalVM, right?
Yeah, I mean that's actually one of the things that I wanted to try out was actually running, building a Micronaut application and trying to do the polyglot stuff as well, like we did with Quarkus. Yeah. That's on my to-do list, so I hope that I'm able to do that some of these days, maybe on vacations.
Would be very interesting to find out. And the last question, like from me coming, this is from me now directly, is
Sure.
when you run those Quarkus microservices in production, right?
Yeah.
When you run them, do you run them on GraalVM or do you use any other JDK distribution?
Open JDK right now because we don't use the native image version. We have long-running servers, so it's preferable right now to the native image version.
Yes.
So you don't use GraalVM even as a JDK, right?
Well, for the polyglot stuff, yes.
Only that, but we have multiple services.
So we have, go ahead.
Yeah, for the services that are not polyglot, we use plain old OpenJDK. For things that use R, we have to use GraalVM because it's required.
Right. Yeah, and I'll tell you the reason for that. So, and maybe that will change. So one of the reasons why we're doing that is because GraalVM until a couple of weeks ago was not supporting Java 11, and we wanted to write things in Java 11. So that was a limitation on the GraalVM side. So we wanted to use Java 11 or 13, and GraalVM was only supporting Java 8. So it was like a limitation. So yeah, we're running, so the GraalVM stuff and our code we're using Java 8, and the rest we wanted to use a more modern version of Java. So that was the reason why we're not using GraalVM for everything. So now I know that GraalVM is supporting 11, so maybe we'll look into it and try to update it.
Oh, absolutely. I would be happy to support you in that on every step. And then I think the absolutely last question, and if you people are watching and if you have any more questions, your time is up. This would be the last, and we will go away, and then you will have to find Roberto and Bruno online. So the last question, and it's to both of you individually, and it comes from Varpen, a member of the YouTube chat. And the question is, what are the top 3 benefits you see in Quarkus for your project, like each of you? And this is not the conclusion that you had, but like your personal opinion, the top 3 things Quarkus offers.
You want to start, Bruno? You're muted.
Yeah, of course I am. So one of the things that probably surprised me the most, and I like it, is the response time from the community. So the Quarkus folks, we had a few problems, a few minor problems, a few others that were more annoying. But most of them, when we wanted to file a bug, there was a bug already there, and sometimes the solution was already implemented, and we were on the cutting edge. But even though things were moving very fast, and that was one of the things that I like the most, is the community is very quick. The other is that the project really feels very contained, and you can like really trim what you are using on your application. It's an improvement for all the standards community, the standard API community, from what we had before. And testing is also super convenient. I like to test things with the Quarkus test because it's quite faster than what we had before with Archilling, for example. So those are the 3 for me.
Yeah, I agree with Bruno with what he said. So I'm going to try to pick 3 different, even though I probably put the community one and the community as number 1 as well, because that's really important. So one of the things is Quarkus makes an opinionated way about a couple of things, which in my opinion, it is great. So for instance, I'm going to give you a very quick example. Quarkus uses Hibernate. Hibernate is the JPA implementation. As in the spec, it says persistence XML is required, so you always have to put the XML file over there. But in the end, it's only just a couple of lines, and it's just annoying to remember to put that over there all the time. And yes, they'll say, well, persistence XML is just going to be optional for us. And yes, it's not JPA compliant, but basically they're sacrificing some of the compliance by convenience. And for advanced users, I think that works very well. And they made that choice in some other cases as well. So they came up with this approach, which I enjoy. Second, of course, I'll add development, the dev mode. Again, dev mode, it's really convenient. And even though I end up developing a lot as a test-driven development, so I don't end up using dev mode that much, but it does shine when you want to do that quick change and want to just debug stuff, and you want to just keep going, and you don't want to stop everything to just make a change, and you don't want to have to write the test, a big complicated test. So it's quite convenient for those use cases. And third, well, it's a really new technology. It's still growing. I see a lot of potential in there. I think we haven't even grasped the entire potential that Quarkus has. So I think people are just trying to learn what to do with that. I think that what we did with the R and the polyglot stuff and the integration with Quarkus and running R with GraalVM was a use case that people haven't thought about yet, and we were happy to think about that for our use case. So that just proves there are a lot of use cases over there that's still waiting for be discovered. So I think there is a lot of potential to discover even more things on what to do with all of these technologies right now.
Right. This is a great response, great answer. Thank you so much to both of you for the session. I really enjoyed the demos. I really enjoyed that there were two of you, so there were no awkward silence when there were issues with the demo, which always happens during presentations. I feel like I should equip myself with a second speaker if I have those.
Oh yeah, that works very well.
Sessions.
Having a second speaker.
I hope you enjoyed doing a virtual jog session. This is probably the last session in the year, so I'm happy that it was this you guys, and I'm happy that this was a good session, inspirational, educational, and as we are stepping into 2020, I think we can hope that it will be a good year of technological advancements for all of us.
Definitely.
So people watching, if you're watching on YouTube, do the necessary YouTube things there. Share, subscribe, like, and everything else that people are doing on YouTube. Join the Virtual Jog community. Join our Slack channel. Just go on the website virtualjog.com, and there are links to all of that. We are trying to be a very nice and friendly community. We have people like Roberto, who is co-leading the Virtual Jog efforts, and we are trying to make sessions every month. So thank you very much once again. I think we have no questions. If you have questions, just find our speakers on Twitter and ask the questions there, or in the Virtual Jog Slack room.
Thanks very much, guys.
Thank you so much for having us, and happy holidays for everyone. And in the end, Oleg's gonna sing a Christmas songs for us.
Oh yeah, happy holidays, everyone. Unfortunately, I cannot sing. It's not a good idea to do that publicly. It's really not. So we are cutting off, and just as a bonus, I will just keep you for 30 more seconds. Is my music teacher in high school said that, like in the middle school, right? They said that the most important quality of a singer is to think, like, to put your soul into the song, right? To make the emotion clear. And I took that to heart. And then in high school, they told me that they will put me the top grades only if I don't actually sing. So since then, I'm kind of not confident enough in my singing abilities. So I will not perform this for you. But happy holidays! It's a great time to reflect on your life career technological choices. It's a great time to just have rest and recuperate and just gather that energy to spearhead the 2020 with to new success. So thanks a lot. We're gonna go away now and see you soon. Maybe in January.
Bye-bye.
Bye-bye.
Bye-bye. Bye.